Yeah. Let's start by completing the lesson that we explained yesterday, which is the system of equations. Okay, as we have solved, if you have equation like this one, x plus 3y equals 7 and x minus y equals negative 1. To solve them algebraically, you can subtract the two equations to get one of the variables. X minus x is 0 and 3x minus negative 1 is 4. 3y minus negative y is 4y equals 7 minus negative 1 is 8. So y equals 2. Okay, and we can substitute to find x. So x minus y equals negative 1, x minus 2 equals negative 1, then x equals 1. Then the solution set will be 2 and 1. And we can graph these two equations in one graph to find the intersection point of the two equations. The first one has x-intercept 7 and y-intercept 7 over 3. This is 2 and this is 3 and 7 over 3 between them. So, and you can graph the line like this one. This is the first line. What was the second line? It has x-intercept is negative 1 and y-intercept is 1. And when you graph this line, this line will intersect the other one at this point. Then the point of intersection is 2 and 1. So the common solution is 2 and 1, which is the order pair. The only order pair satisfy both of them. So each equation has an infinite number of order pairs or an infinite number of solutions satisfy this equation, and the other also has an infinite number of solutions. But both equations has only one solution that satisfy both of them. This solution, these two equations is 2 and 1. So 2 and 1 satisfy both of them. Then we can say that the 2 and 1 is a common solution or the solution set of these two equations. It's okay. Another case of the equations, x plus 2y equals 5 and 2x plus 4y equals 7. When you multiply this equation by 2 to solve the equations, you will get 2x plus 4y equals 7. If you subtract them, you will find 7 equals 0, and this is impossible, so there is no solution between the two equations. So try to graph these two equations. The first one has x-intercept 7 over 2, this is 3, and this is 4, and 7 over 2 between them, 7 over 2. And the second is 7 over 4, 1, 2, 7 over 4 is between them. This is the first line. What was the second line? Is 5 over 2. Y-intercept is 5 over 2, and x-intercept is 5. 7 over 4 and 7 over 2. Okay. This one is 5. And this 5 over 2, which is 2.5. And when you graph this line, you will find the two lines are parallel. Then there is no common solutions between them. Okay, so A1 over A2 equals B1 over B2. If A1 over A2 equals B1 over B2 not equal C1 over C2, then the two lines are parallel and there is no common solution because they have the same slopes. Okay, very good. The third case, if the two equations are different forms of one of them, like this one, 2x plus y equal 3 and 4x plus 2y equals 6. You will find the two equations are two different forms of one of them. So if you multiply the first one by 2, you will get the second one. Or if you divide the second one by 2, you will get the first one. So the two equations are the same. Then they have an infinite number of solutions and they are represented by two coincident lines. Let me represent the two equations like this one. X is 3 over 2 is 1 and 2, and this is 3 over 2. And y-intercept is 3. And grab the first line. This is the first line. Okay. Let me represent the second one. The x-intercept is also 3 over 2. Another color of x-intercept is 3 over 2 and y-intercept is 6 over 2, which is the same point, 3. And when you grab the other line, you will find them one straight line or coincident. So the two equations have infinite number of solutions. Why? Because A1 over A2 equals B1 over B2 equals C1 over C2. They have the same slopes and same y-intercept. Then they are coincident, or they have an infinite number of solutions. Okay? Let me give you some examples. Solve and find the number of solutions. Number one, 5x minus y equals 7 and x plus y equals 3. When you add these two equations, because they have the same y coefficients and with opposite signs, you will get 6x equals, what's this 4? Okay, it's 5. Okay, 6x equals 12, then x equals 2. Okay, substituting one of them like this one, 2 plus y equals 5, then y equals 3. Then the common solution is 2 and 3. This order pair is the only order pair satisfy both of them. And you have A1 over A2 equals 5 over 1, which is 5, and B1 over B2 equals negative 1. Then A1 over A2 is not equal B1 over B2. Then the two equations have one solution or intersecting line. Intersect lines if you represent them in the number line. Okay. Solve this exercise and send them in the homework file, please. Number one, x plus 3y equals 7, x minus y equals negative 1. Number two, 2x plus y equals 4, and 4x plus 2y equals negative 1. Number three, 7x equals 2y, and 2x minus 4y equals 8. Number four, x plus 3y equals 5, 2x plus 6y equals 10. Okay, thank you very much.